Technology problem today. A 670 milliliter aliquot of 0.670 molarity aqueous potassium hydroxide is mixed with 670 milliliters of a 0.670 molarity aqueous magnesium nitrate. Alright, I've got a few things set up right here. This is just my molarity triangle, moles over molarity times volume. I have my 4 ions I'm trying to find. And then I have empty beaker set up just as an example what we will use later. But first, the most important thing we do is we, set up an equation. First going to be, or I guess I'll write this a little bit further over. KOH. And then this is going to be aqueous because it's a hydroxide, which all hydroxides can act as acids, but potassium hydroxide is going to be aqueous. And then you're going to add, it's going to be magnesium nitrate. And that's going to yield magnesium, or apologies, I should probably go back for them real quick. This is going to be aqueous as well. Due to your solubility rules, nitrates are aqueous, or weak electrolytes, or strong electrolytes, I apologize. So they disassociate. And then this will yield magnesium hydroxide, which is going to be our solid in this because of our solubility rules. It's a weak electrolyte, so it does not disassociate. And then you're going to add that potassium nitrate. And then that's aqueous because it's a nitrate as well. And you're going to need to balance it. So now we need to put a 2 right here. And we're going to throw 2 right here. And I believe our reaction should be balanced. Right. And as we can see, our precipitant in this reaction is going to be the one solid we have. It's our magnesium hydroxide. So I'm going to first go on and label that in my beaker. Magnesium hydroxide. And we know that's our precipitant. Right. Thinking. All right. We're first going to pay attention to which of these 2 reactants are our limiting reactant. So we'll first start with KOH. And here's the molar map for that. Molarity volume of KOH plus the moles of KOH to the, I guess, put a little arrow here, to the moles of magnesium hydroxide. All right, so that's going to go ahead and be our 0.670 liters of KOH and then it's just times, that's our volume, so we're going to times that by molarity too. So 1 liter is 0.670 moles of KOH. And then to go from moles to moles, you'll use your molar ratio. Apologies. Which is going to go ahead and be 1 mole of MgOH2 over 2 moles of KOH, which is then going to give us, let's add that up. So we have our 0.6700 times our 0.670, which is going to give us our first mole. I'll go ahead and write that above here. 0.4489. Then we'll go on to here, and it's there's 2 moles of KOH, so we'll have to divide that by 2. And then we get 0.2245 moles of magnesium hydroxide are made from potassium hydroxide. Moving on, this problem is pretty straightforward considering your numbers are not too different for both the substances. So next we are going to be doing the same thing, but for the magnesium nitrate, how much it makes of the magnesium hydroxide. Alrighty, so molar map is going to be, again, molarity volume of, this is going to be magnesium nitrate. Trying my best here. And then that's going to go to the moles of magnesium nitrate. And that's going to go to the moles of magnesium hydroxide, which is therefore going to be 0.6700 liters. And then again, times our 1 liter is equal to 0.670 moles of magnesium nitrate. And then that's going to go ahead and give me the same number, 0.4489. And I like to record that as well. And then, of course, molar ratio. And then let's look. There's 1 to 1. So 1 mole, 1 mole. And that's going to be of my units, which is therefore still going to give me that 0.44, what was it, 89. And so from this, and that's moles of magnesium writing the wrong way, hydroxide. Alrighty. From there, I forgot a step. Let me go ahead and move this down. One of the most, or I guess I shall just write it right here. One of the most important things you need to do before this all is write a molecular and a net ionic equation, which I'm going to go ahead and do right now. So you have 2K plus, which is aqueous, plus 1 OH minus, which is aqueous, plus the magnesium, 2 plus, aqueous, plus our nitrate, plus our 2NO3, minus, and that's aqueous as well. And we move over, and this is going to be a solid. It's a weak electrolyte. It does not dissociate, so therefore we're still going to keep our magnesium hydroxide solid. And then this is plus 2K plus aqueous plus 2NO3 minus aqueous. Alrighty. And this is just figuring out our spectator ions, right? And we can easily identify that by crossing out 2, there, and there. So we already know we have 2K plus and 2 nitrate on each side of our reaction, and these dissociate. So therefore you're going to have 2 nitrate and 2 potassium floating around in your solution. So you need to press K plus NO3 minus NO3 minus. And writing this, you can just write your net ionic equation, which is just going to be the Mg2 plus aqueous plus the OH minus aqueous. You know what or no, I did not. Or yes, I did. This is going to be 2 OH minus. Knew something funny. 2 OH minus, which is going to yield that magnesium hydroxide. All right. And furthermore, looking at this, we can sit there and see that KOH is our limiting reagent. So therefore, all your KOH, or more specifically, or 1 minute, let me check my math. I want to make sure I do this correctly. Just thinking, please bear with me here. All right, here. Took me a minute to think, but let's go to the next step. Considering that we've identified that K is our spectating ion, we only have our hydroxide left. So, or at least for part of our KOH, that's already out. We already know that we have spectator ions, but our hydroxide has been all used up. So therefore, your hydroxide is gone. So we can sit there and we can say the hydroxide is net zero because it's all been absorbed in that precipitate. All right, moving on. Oh, getting slow but steady. So now I'm going to go ahead and I'm going to take my moles of my magnesium nitrate and put it to my moles of Mg2 plus to figure out eventually my molarity. All right. And we'll do the math for that. So that's 0.4489 moles of MgNO3. And for that, you'll have to use your molar ratio because you're going mole to mole. And so you have 1 mole of Mg2 plus for every 1 mole of MgNO3 2, which is still going to give you your 0.4489, looks like G9 mole of Mg2 plus. Right. And we're going to do this the same thing for potassium hydroxide as well. So you go from moles of KOH to the moles of Mg2 plus. So you're still going to have that 0.4489 mole I believe. Yes, I'm doing this correctly. Mole of KOH. And then you're going to do molar ratio again. But instead, this time, 1 mole of Mg2 plus is equal to 2 moles of KOH, which then equals 0.2245 moles of Mg2 plus. And this is the reacted. And so from there, we're going to go ahead and we'll squeeze this. I guess I'll just continue to go down. My molarity of Mg2 plus is going to be equal to that 0.4489 minus 0.2245 all over the 0.6700 liters plus that again 0.6700 liters, and then these are both mole of Mg, which therefore that math should give me, if I'm correct, equal 0.168 molarity for Mg plus 2. let's see what that was again. It was 0.168. All right. Now we're just looking for the concentration of our spectator ions. I forgot to notice as well that considering that hydroxide has already been all run out in this reaction, it's all in our precipitant, we're going to have at least a little bit of magnesium left in the solution as a I can't think of the word, I'm sorry, an excess. So you're going to go ahead and you're going to have that Mg2 plus in excess. All right. And then moving on. All right. We'll go onto our spectator ions. So we'll start off looking for K. So I'm going to start off with my moles of KOH, and then I'm going to go ahead and do my moles of K plus, which is just going to give me my 0.4489 moles of KOH. And I am going to use my molar ratio once again. And let me look up. I believe it is a 1-to-1. Yes, it is a 1-to-1. 1 mole KOH is 1 mole of K plus. And that is going to equal, again, just the 0.4489 moles of K plus. And then now I'm going to do the same thing, but for magnesium. Or not magnesium, nitrate. But magnesium nitrate is what I will be beginning with. So again, I'll still have my moles. Let me do my map. My moles of magnesium nitrate to my moles of NO3. Alrighty. So 0.4489 moles of MgNO3 and we'll just use our molar ratio again, but I believe this time, yes, it is going to be a 2 moles of NO3 for 1 mole of MgNO3, which is then going to give me 0.4489 multiplied by 2, which is going to be 0.8978. Moles of NO3. Alrighty. And then from there, you're pretty much just going to convert that to molarity. Sorry, need a minute. Let's move on. And to find the molarity, let me write this down. Molarity of K plus, you're going to use, I guess I should use an equal sign instead. Better one, there we go. it's going to be that you're pretty much N over V. I believe maybe I'm just saying that wrong, but let's go ahead and do this math. So I know for sure that it was at 0.489 moles of K plus. And then I'm going to do that's over my volume. So I'm just going to go ahead and add, just so I don't have to do too much more math. It's going to be 0.6700 plus 0.6700. And then it's going to be 1.34. It's going to be my total total volume in liters. And then from there, moles over liter equals molarity. So from there, we're going to be 0.4489 divided by 1.34. It's going to give you 0.335 m of K plus. So we'll go ahead and add this up here. Right, moving on. I believe I'm doing this correctly. That's only one way to see. So now we're moving on to the molarity of nitrate. All right. And that is going to go ahead and be this number right here. And then over your total volume once again. So that's going to be 0.8978 all over, or I guess I should make sure I put moles of NO3. Yes, and then that's going to be my 1.34 liters as a whole, which is still going to give me, let's do that math, which is going to be 0.8978 divided by 1.34 is going to be 0.670. And then that's the molarity of nitrate. Right. And I'm going to go ahead and enlarge this too, just so you can see all of my work clearly. And then we'll go ahead and make this equation a little bit bigger as well. Want to make sure everyone can see it. I tried my best for this problem. I might still need I'm sure I still need some work, but I would love to know what mistakes I might have made. Righty. And I believe that should be all. We have our answers right here. For K plus, it is 0.335 molarity. For OH minus, that was all used up in our precipitant, so it's 0. It's all up in here. And next, our magnesium is done because we have our 1.68 right here, just because we subtracted our original from our limiting, and we found what we had in excess. And then furthermore, lastly, but surely not least, we found our nitrate. And let me go ahead We color code this. I just want it to be very clear for everyone to see. I'll even put a little bit of that in here just so you can recognize that all of that hydroxide went into that precipitant, and you still have a little bit of that magnesium in excess as well. All right, and we'll get that green and just add that onto that K plus too. You can't forget about them. All right. Again, reviewing, you had to really have your net ionic equation to be successful in this problem. But the main thing is first identifying your limiting reagent and then taking that and finding your ions concentration from it. Again, just scrolling over my work. I believe everything should be correct. And that should be all for today. Thank you.